According to the 2017 National Electrical Code, specifically Section 300.3c2, it is generally not permissible to mix 480 volts and 5 kilovolts cables in the same manhole without adequate separation. This section mandates a minimum separation of 6 feet between conductors of different systems. This requirement aims to mitigate potential hazards associated with voltage differences and ensure the safety of personnel and equipment. The primary rationale behind this regulation is to prevent electrical faults such as arcing or insulation breakdown, which could occur if conductors of significantly different voltage levels are placed in close proximity. A voltage difference creates an electrical field, and if the insulation between conductors is insufficient or compromised, the electrical field can cause a discharge, leading to a short circuit or other fault condition. Such faults can result in equipment damage, power outages, and, most importantly, pose a significant safety risk to individuals working in or around the manhole. The 6-foot separation requirement provides a buffer zone that reduces the likelihood of these electrical faults by minimizing the strength of the electrical field between the conductors. However, the NEC recognizes that achieving 6-foot separation may not always be feasible due to space constraints or other practical considerations. In such cases, the code allows for the use of a barrier as an alternative to physical separation. A barrier is a non-conductive material that is placed between the conductors to provide electrical insulation and physical separation. The barrier must be designed and installed in a manner that effectively prevents electrical faults and provides a level of protection equivalent to the 6-foot separation requirement. Several factors must be considered when selecting and installing a barrier. Firstly, the barrier material must be suitable for the environmental conditions within the manhole, including temperature, humidity, and exposure to chemicals or other contaminants. The material must be resistant to degradation and maintain its insulating properties over time. Secondly, the barrier must be of sufficient size and thickness to provide adequate electrical insulation. The specific dimensions of the barrier will depend on the voltage levels of the conductors and the electrical properties of the barrier material. Thirdly, the barrier must be securely installed to prevent it from shifting or dislodging, which could compromise its effectiveness. The installation method should be appropriate for the type of barrier and the construction of the manhole. In addition to these general requirements, the NEC may specify additional requirements for barriers in specific applications. For example, the code may require that barriers be marked or labeled to indicate their presence and purpose. It is essential to consult the NEC and other applicable standards to ensure that the barrier meets all relevant requirements. It is also important to note that the NEC is not the only source of information on safe electrical practices. Other industry standards, such as those published by the Institute of Electrical and Electronics Engineers, and manufacturer recommendations can provide valuable guidance on the proper installation and maintenance of electrical equipment. Furthermore, it is crucial to ensure that all personnel working on or around electrical equipment are properly trained and qualified. Training should cover topics such as electrical safety, hazard recognition, and the use of personal protective equipment. Qualified personnel should be familiar with the NEC and other applicable standards and have the skills and knowledge necessary to perform electrical work safely and effectively. In summary, while mixing 480 volts and 5 kilovolts cables in the same manhole is generally not permitted without a minimum of 6 feet of separation, a barrier can be used as an alternative. When using a barrier, it must be properly selected, installed, and maintained to ensure that it provides adequate electrical insulation and physical separation. Consulting the NEC, other applicable standards, and qualified personnel is essential to ensure compliance and safety. Additionally, consider the specific application and environment of the electrical installation. For instance, in areas with high humidity or corrosive environments, the choice of cable insulation and the barrier material becomes even more critical. Cables should be selected with appropriate insulation ratings to withstand the voltage stress and environmental factors. Common insulation materials include cross-linked polyethylene, ethylene propylene rubber, and polyvinyl chloride, each with its own advantages and limitations regarding temperature range, chemical resistance, and dielectric strength. The barrier material should also be chosen to resist degradation from moisture, chemicals, or ultraviolet radiation, if applicable. Regular inspections and maintenance are crucial for ensuring the long-term integrity of both the cables and the barrier. Inspections should include visual checks for signs of damage to the cable insulation, such as cracks, abrasions, or discoloration. The barrier should also be inspected for any signs of deterioration, such as cracking, warping, or chemical attack. Any damaged components should be replaced promptly to prevent potential electrical hazards. Proper grounding and bonding are also essential for electrical safety in manholes. Grounding provides a path for fault current to flow back to the source, allowing protective devices, such as circuit breakers or fuses, to quickly de-energize the circuit in the event of a fault. Bonding ensures that all metallic components within the manhole are at the same electrical potential, reducing the risk of electric shock. The grounding and bonding system should be designed and installed in accordance with the NEC and other applicable standards. Furthermore, the manhole itself should be adequately ventilated to prevent the buildup of hazardous gases or vapors. Electrical equipment can generate heat, and in confined spaces, this heat can cause the temperature to rise, potentially leading to equipment failure or even fire. Ventilation helps to dissipate heat and maintain a safe operating temperature. If the manhole is located in an area where flooding is possible, measures should be taken to prevent water from entering the manhole. Water can damage electrical equipment and create a shock hazard. This may involve sealing the manhole cover or installing a sump pump to remove any water that does enter. Finally, proper signage and labeling are important for identifying electrical equipment and warning personnel of potential hazards. The manhole cover should be clearly marked with a warning sign indicating the presence of electrical equipment. Cables and other components within the manhole should be labeled to identify their voltage and function. This information can help prevent accidental contact with energized equipment and facilitate maintenance and repairs. It is also important to document the electrical installation, including the location of cables, the type of insulation, the barrier material, and the grounding and bonding system. This documentation can be helpful for future maintenance and troubleshooting. In conclusion, while mixing 480 volts and 5 kilovolts cables in the same manhole may be possible with a barrier, careful consideration must be given to the selection, installation, and maintenance of the barrier, as well as the cable insulation, grounding and bonding system, ventilation, and signage. Adhering to the NEC and other applicable standards is essential for ensuring the safety of personnel and equipment. The 2017 National Electrical Code Section 300.3C2 provides a clear guideline, and any deviation from this guideline necessitates a well-engineered solution, often involving the use of a suitable barrier. This barrier must be composed of a material with appropriate dielectric strength and physical properties to withstand the environmental conditions within the manhole. It should effectively prevent flashover or arcing between the 480 volts and 5 kilovolts cables. The selection of the barrier material should take into account factors such as temperature range, moisture resistance, chemical compatibility, and mechanical strength. The barrier should be installed in a manner that provides complete separation between the cables, preventing any direct contact or close proximity that could compromise insulation integrity. In addition to the barrier, it is essential to ensure that the cables themselves are properly rated for their respective voltage levels and environmental conditions. The cable insulation should be inspected for any signs of damage or degradation, and any damaged cable should be replaced immediately. Furthermore, the manhole should be equipped with adequate grounding and bonding to minimize the risk of electric shock. All metallic components within the manhole, including cable trays, conduits, and equipment enclosures, should be bonded together and connected to a grounding electrode system. This grounding system should comply with the requirements of the NEC and other applicable standards. Regular inspections and maintenance of the manhole are crucial for ensuring the continued safety and reliability of the electrical system. Inspections should include visual checks for signs of damage or deterioration to the cable's barrier, grounding system, and other components. Any deficiencies should be addressed promptly to prevent potential hazards. In some cases, it may be necessary to install additional safety measures, such as warning signs or protective barriers to alert personnel to the presence of high-voltage cables. These measures can help to prevent accidental contact with energized equipment and reduce the risk of electric shock. The design and installation of electrical systems in manholes should be performed by qualified personnel who are familiar with the NEC and other applicable standards. These personnel should have the training and experience necessary to ensure that the system is installed safely and correctly. Furthermore, it is important to document the electrical installation, including the location of cables, the type of insulation, the barrier material, and the grounding system. This documentation can be helpful for future maintenance and troubleshooting. In summary, mixing 480 volts and 5 kilovolts cables in the same manhole requires careful consideration of safety and code compliance. While a barrier can be used to provide the necessary separation, it is essential to ensure that the barrier is properly selected, installed, and maintained. Additionally, the cables, grounding system, and other components must be inspected regularly and maintained in good condition. By following these guidelines, it is possible to safely and reliably operate electrical systems in manholes. In addition to the physical separation and insulation provided by the barrier and cable insulation, it's important to consider the potential for induced voltages on the low voltage cables due to the proximity of the higher voltage cables. This phenomenon, known as inductive coupling, can occur when conductors carrying alternating current are placed near each other. The magnetic field generated by the higher voltage cable can induce a voltage in the lower voltage cable, potentially creating a shock hazard or interfering with the operation of sensitive electronic equipment. To mitigate the effects of inductive coupling, several techniques can be employed. Firstly, the cables can be routed in a manner that minimizes their parallel run length. By keeping the cables as far apart as possible and avoiding long parallel runs, the inductive coupling can be reduced. Secondly, shielded cables can be used to reduce the amount of electromagnetic interference. Shielded cables have a conductive layer that surrounds the inner conductors, which helps to block electromagnetic fields. Thirdly, grounding and bonding can be used to provide a path for induced currents to flow back to the source. By properly grounding and bonding all metallic components within the manhole, the potential for shock hazards can be minimized. Furthermore, it is important to consider the potential for transient voltages caused by lightning strikes or switching surges. These transient voltages can be much higher than the normal operating voltage and can damage electrical equipment. To protect against transient voltages, surge protective devices should be installed. Surge protective devices are designed to divert transient voltages to ground, preventing them from reaching sensitive equipment. The selection of surge protective devices should be based on the voltage levels and surge current capabilities of the electrical system. In addition to these technical considerations, it is important to follow safe work practices when working in manholes. Manholes can be confined spaces, and there are several hazards associated with working in confined spaces, including oxygen deficiency, toxic acids, and explosive atmospheres. Before entering a manhole, the atmosphere should be tested to ensure that it is safe to breathe. If the atmosphere is not safe, ventilation should be provided to remove any hazardous gases or vapors. Personnel working in manholes should be trained in confined space entry procedures and should wear appropriate personal protective equipment, such as respirators and safety harnesses. In summary, mixing 480 volts and 5 kilovolts cables in the same manhole requires careful consideration of safety and code compliance. In addition to the physical separation and insulation provided by the barrier and cable insulation, it is important to consider the potential for induced voltages and transient voltages. By following safe work practices and using appropriate protective equipment, it is possible to safely and reliably operate electrical systems in manholes.